All right, so what we have here is practice 4 dot product. And this model right here specifically represents something. And we talked about it in our do we do part 1 before the break? Yeah. And our part 1 notes. This represents linear transformations. So if I had a linear transformation, if I wanted to write this as a linear transformation, this is telling me that t given 2, 3 equals, and I'm going to write it out, 3x minus y, comma, 4x plus 0y. That's what this represents. It's a linear transformation model, but written as a matrix. Do you remember writing these in part 1 of our notes? Where you had to convert between the two? That's what this is. So this matrix represents that situation. And it's say, okay, instead of you having to substitute, we're going to use matrix multiplication to evaluate to find that transform point. All right. So how does that work? You're going to follow the row matrix, what we just did. So we're going to do the multiplication. So this all leads to, I'm going to need space over here. I know that this works because I have a 2 by 2 times a 2 by 1. Do they smile at me? Yes. And they're going to produce a 2 by 1. Do we see that? They smile, check. They're going to produce a 2 by 1. So multiplication begins. Here we go. First in row times first in column. So that gives me 3 times 2, right? Plus second in row times second in column. That gives me -1 times 3. Yeah? Are we okay? Now we're going to do the next row. I didn't leave enough room on mine, but I'm going to write it. So first in row times first in column. So that's going to be 4 times 2. Second in row times second in column. That's going to be 0 times 3. That is my product matrix. I'm going to clean it up. 3 times 2 is 6. -1 times 3 is 4 times 2 is 0 times 3 is 0. So what is my solution? Say that again.
How come there's a minus from 8 minus 0?
Because I just didn't make it. The line. Does it really matter if I subtract or add 0?
It really does.
It does? Oh, okay, cool. All right. Yes?
Yeah.
So if you look at it in this sense, is this not exactly what we did? Did we not do 3 times 2? Yeah, we did. Did we not do -1 times 3? We did. They all go together, okay? The only difference is that they say, okay, let's eliminate the variable aspect and only focus on the numbers. So what this means is if I'm at 3, 8, that means in terms of an ordered pair, this is 3, 8. Okay, we're going to do number 2 together, and then we'll have you do 3 and 4. Is that cool? All right, here we go. First in row times first in column. So that gives me -5 times 1 plus second in row times second in column. That gives me 0 times 7. That is my first element completed. I have no more rows to go. Does that make sense? Next, we're going to do first in row times first in column. So that's 3 times 1 plus second in row times second in column. 1 times 7. We're going to simplify. -5 times 1 is -5. 0 times 7 is 0. 3 times 1 is 3. 1 times 7 is 7. It happens to the best of us. It's early. Leave them alone. All right. -5 plus 0 is? And then 3 plus 7 is? So that is my 2 by 1 product. If I had to write it as an ordered pair, it would be -5, 10. Was it terrible? What makes it terrible? Using those elementary school skills, I knew it. Darn you, multiplying and adding. All right, I'm gonna give you 4 minutes to do 3 and 4. I will be walking around to help. If you need me, please let me know. But you're now gonna do 3 and 4. All right, let's see how much longer Luke has on this phone. We have about 2 minutes left.
You did this. No, like, well, 2 times 2 is.
It's like we do one, but you don't want to like, well, no, don't want to chew it.
So we have to do that.
Don't bite it. Don't bite it. Don't bite it. I told you not to bite it. All right. I'll get it. See how we did. So on the first one, we should have did 1 times -2 plus -4 times 3. Yeah. Then we had 12 times -2 plus 3 times 3. Yeah. And we're doing good. -2 minus 12. -24 plus 9. And we end up with negative 14 and negative 15. Yeah? Yes, good job, guys. All right. So we have, last one, we have 3 times negative 2 plus 7 times negative 5. Then we had 2 times negative 2 plus 1 times negative 5. How we do? Good. So that gives us negative 6 minus 35, negative 4 minus 5. And we ended up with negative 41 and negative 9. Easy? Doable? Yes. I don't plan on giving anything bigger than that, except on your homework, just to challenge you. Yeah. All right. Yes, I feel so good. So now that we're here, so coming to the conclusion and writing it, what we're going to do is we're just going to rewrite it, the matrices, and turn each one into a transformation. That's it. Okay. I just want you to write it in its transformation form. We already did number 1 together, right? So we already wrote number 1 in its transformation form, and we already found its result, correct? That is all we're doing on practice 5. All right. So I'm going to do number 1 because I've already did it. So number 1, our transformation form was T 2, 3 equaled, forgot that quick, 3x minus y, comma, you guys could tell me, but y'all just gonna let me keep going back, 4x plus 0y. And what was our result as an ordered pair? 3, 8. Okay, that is all you're doing. So you're taking the matrices and writing them in coordinate function form. And then what the matrix product would be as an ordered pair. Got it? All right, that's it. We did it. Now, we're so smart. All right, gonna find another song to time us out. Let Miguel do it. 3 minutes with Miguel. X, Y, I think Miguel's almost done serenading us. About 1 minute left. We check ourselves.
Well, no, well, it's sugar maple.
Who? We did? Yeah, let's take this off.
I would never had it.
Are we done before Miguel's done singing?
Yes.
All right. Let's see how we did. Was it terrible? It was. Oh no. All right. So here First one, we had transforming 1, 7, right? So we're on the second one. So your matrix should have been negative 5x plus your transformation coordinate function should be negative 5x plus 0y, comma 3x plus y. And what was our output? Negative 5, 10, right?
Yeah.
Yeah. Rewriting this into coordinate function form. Number 3. So we had t negative 2, 3 equal, and you should have had x minus 4y, comma 12x plus 3y. How'd we do? And what was your output? Negative what? There we go. 14, right? There. All right. Last t, negative 2, negative 5 equal. And again, we're on 4. So you should add 3x plus 7y. And then 2x minus y. How do we do? And what's its output? Negative 41, comma. Oh, my negative on my 15?
Yeah, and for the y.
Whatever.
Whereas that would be a positive.
Oh, it is. Thank you. All right. Yes.
Yeah.
Terrible? Doable? Doable. All right. So what you need to say, if you believe in these things, I can add and subtract and scalar multiply matrices. Yes or no? Yes. I can determine the transformation of point using coordinate function. So the t, comma, blah, blah, blah. And I can determine the transformation of point using a matrix. Yes, that's supposed to say multiplication, not duplication. I have no clue why it says duplication. Okay. All right. Your Canvas assignment awaits you. All right. Your Canvas assignment is meant to be a little more challenging. So you do have bigger than just 2x2s and 2x1s to multiply. Okay. I did a 3.
In 3 minutes?
No, altogether your assignment, max 45 minutes.
So I'm not.
Yeah.
And I